Does everyone have IntelliJ installed and ready? Good to go? Okay, great. Okay, so my name is Bill Goldsworthy. I'm a Scala developer here at BottleRocket. Thanks for coming. We'll be talking about a number of things. The first thing I wanted to touch on was just to extend what Brian had been talking about with FlatMap with another example. So I just wanted to show, just give another example I thought might be helpful. So say that we have a function, right, that takes, this is really a contrived example, but it's int to double, right? It takes an int and it returns option of double, right?
Can you increase the size? Like
is that too small?
Yeah.
Sure.
Double, please.
Please and thank you.
Oh,
okay.
sorry.
That's great.
All right, so it's just a really, simple function called int to double. Takes an int, right, and it returns option of double. And then say we have sum of 10, right? So we have option of an int, and then we map and we pass it that function, right? So map takes a type of A and it transforms it into type of B, right? But our function is our A is an int and our B is option of double, right? So when we have an option and we map that function, it actually returns option of double, right? Which isn't what we want. That's not helpful to us. So that's when flat map is helpful, right? Because you can flat map and it's going to remove, and give you that final type that you want, which I'll show for the example. Right, so now we end up with what we want. So it's a way you can chain functions of types like this, right, and end up with what you want. So just wanted to point that out. Okay. So in this section, we're going to be looking at more at the actual application development for a Scala program. In Mark's segment, he'll be doing much greater depth. This is just sort of the beginnings. So on the Scala Essentials site, under Section 3, there's this link to the simple app, if you could clone that locally. I don't know if everyone's done that or not. And then, so what I'm going to do is I'm going to follow the schedule. Okay, so the first thing is SVT. So SVT is the simple build tool. It's sort of the common, most commonly used build tool for Scala. You can use Gradle, you can use Maven. A lot of Scala folks use SVT. So there's a couple links here. A book, SVT in Action. Twitter Scala School has some information on SVT, and then just documentations. SVT can be a lot to get your head around, but so we're just going to focus on basic application structure and how we can get moving. All right, but before we do that, we need to, first off, how many, show of hands, how many people are familiar with IntelliJ or using IntelliJ? Okay. So it's an IDE, right? Same as Eclipse or one of the other things. And what I want to do first is, let's talk about IntelliJ for a little bit. So start it up. All right. So for those of you who just installed it, the first thing to mention, where is my mouse? Sorry, I was in track. Is that under Configure, Plugins? I don't know. It's been such a long time. Did Mark leave? Is the Scala plugin? Oh, there is the Scala plugin installed by default, or do I need?
The Scala plugin is not installed by default. You must install it up front. Is the very first thing to do. I apologize for not telling you that. That was a bit of magic knowledge you had to have figured out yourself. But this is how to install that plugin.
Oh, if you haven't done so already.
Reboot your system.
Yeah.
That's IntelliJ.
As we found out earlier, if you had the misfortune of Git cloning the project and then importing that into IntelliJ before you install the Scala plugin, unfortunately that project, you'll need to delete that project, install the Scala plugin, and then re-import it and things will work correctly. So that's actually what, sorry guys, so that is the order of operations you have to enter. Oh no.
Okay, so should I give folks a minute to do that, or just continue? I'll give a minute to go ahead and get that plugin installed because it's crucial.
Okay, I downloaded the thing from Git.
Okay, go to SBT.
Oh, I got SBT now.
Yep, yeah, that one, click the SBT item
Oh,
there.
okay.
Wait a minute, did it hit back? Something didn't work. Import from do SBT. Click the same button, SBT. So click that, yeah, and now click SBT. There we go. That hit it.
Alright, and that's good.
1.072, is that the latest? Is that the right version? I think you gotta have a more recent version of the Java. Yeah, you need 9.1 or newer. So you have to, so if you, yeah, either that, you're gonna have to get the updated version of Java 1.8. Get it installed.
Yes. Here, system preferences.
You're gonna have to install the JDK.
This one.
I don't think, that, yeah, that's just Java preferences. Unless there's a way to do it from there. I've never done it from there. Oh no, that's the JRE. You gotta go do the JDK.
So I gotta go down on
Yeah, you gotta go install the Java SDK or the JDK.
the. Okay.
Yeah.
Here. Java 8, check.
Yeah, that's the one. All you're doing is do the same thing. I wonder if that's on here. Everyone's ready to go?
All right. So to get our project, which you know, I've pulled the project down from GitHub, and I want to import it into IntelliJ. Right. So Scala Essentials. Choose the project. Right. It's an SVT project. Gives us some options here. Auto import is like if you've made changes to the build file and the IntelliJ automatically refresh. Create directories. I mean, you don't really worry about these right now. You just point them out. Also, you can specify if you want the Java docs and sources and things downloaded from all your dependencies. If you should so want, choose the Java SDK that you want. Hit finish. All right, so it's going to ask you the modules to import. It's a single project build, so everything's great. We just hit OK. Great. So IntelliJ is going to work for a bit, and then we'll have our workspace. This way. Okay, so open up the left here, and we'll talk a bit about our project structure. So the main, to keep things simple, right? In the root directory of your project, you're going to have build.svt. This is essentially your build file, right? And there's a lot of customization that can happen here. There's actually, this is written in this DSL type thing. You can create, more complex builds under project, but we're not going to get into any of that. We're just going to talk about the basics. So as you can see, we're specifying some basic information about our project, our name, organization, the version of Scala that we're using, the version of our project, and library dependencies, right? So here we're just including Scala tests. So Scala tests you can think of like JUnit, or it's basically a unit testing framework. So for additional libraries, right, you can add additional things like this. You can also choose. Stop. Contain, the sequence of all your different libraries that you want, whatever you want to do.
Wherever you put it, I don't actually know if it will give it, it will put it on the master, but
We already went through the install. I double clicked on that. And
Some other things I want to mention is build.properties under the project folder contains the version of SVT that we're going to be using. In addition, in this folder you can have a file called plugins.svt. So SVT has third-party plugins and whatnot that you can download and use. That's where you would list them. All right. Any questions so far? It's pretty basic stuff. All right, so the next thing is, where does our source code go, right? So it's Maven style. We have source, main, Scala, right? Our package name. Our tests go under tests. You can configure SVT to turn on integration tests and have a folder called it if you wanted. You can separate those tests out from your unit tests. But we'll be digging into this stuff and what's there. But before we go further into the project, let's talk a bit about IntelliJ key commands. And back on the Scala Essentials site, oops. There's some links here. I thought I saw them. Maybe they're back under resources that basically with helpful key commands and kind of stuff like that. A couple that I want to talk about that are relevant to Scala are is if you do Control-Shift-A. Let's see. Oh, actually, I may have Linux bindings, and I'm using a Mac right now.
Command-Shift-A.
Is it Command-Shift-A? Oh, thank you. Is find action by name, right? So just different actions that are available in the in the application. You can do Shift-Shift, and that searches everywhere, right? So, right? Oh, okay. I can jump to my unit test really easily, right? Same as Command O, right? Allows you to search class names so you can get around your project easily. There's also some neat things like to point out is code completion. So controls. Oops. A lot of times IntelliJ will, figure out what you're trying to do and give you the nice code completion. You can also trigger that using control space. And then there's two. I mean, that's all kind of basic stuff that everyone pretty much knows in some form. But there's two things that I really wanted to point out. And so as you are learning more about Scala, there's I know when I first started, you start getting the feeling there's just a lot of magic happening behind the scenes and you can't see it. And some of that magic is from things called implicits. So I'm not going to delve into fully what implicits are. I just kind of want to show two examples and then how you can use the Scala plugin to show you what's happening so there's not magic, right? The first of those is implicit conversions. So an implicit conversion you could use to say you have a bunch of transformation code or you're going from this type to that type and it's mucking up your code, it's making everything kind of hard to read. So you create an implicit conversion and then it just kind of does it for you behind the scenes. But if you don't know that's there and that's happening, right, you'd be pulling your hair out. So let's give an example. So, so here I've declared val dark magic string equals 1024. Right? Normally that statement wouldn't compile. But we've got this implicit declaration here that's doing that conversion for us. Right? So if I hold command down and hover over this, right, it pops up information about what this is. So I don't, you can see that that's a string. So if you do, Command Shift, hover over this, Command Shift P, Q, no, Control Shift Q, Control Shift Q, why is this not working? This one? Yeah, thank you. I did this on all these examples on home on Linux, and everything was great. So, apologize. What am I doing wrong? Okay. All right. Well, I guess I don't know what the Mac key, but basically, it would pop up and show you what implicit conversion was being applied there. You could jump to that function.
Not showing you the squiggly?
You can see that it's underlined here.
Yeah.
But you're supposed to be able to do, I thought it was Control Shift Q. That's
so
what
you got a little bulb there. Pop to the bulb and see if it gives you anything. No. You got a menu there. Yeah. There you go.
So
now it's telling you, yeah, that was a replacement.
Right.
You can also get a pop-up that will tell you that's what it's going to do right there.
Yeah, and that's what I'm trying. I thought I could trigger with Control Shift Q, but it's not.
Uh-huh.
There it is. Control Q on the Mac.
Control Q. Okay, very nice. Well, that's really important.
Yeah. All right, so as you can see, right, and then you can jump to where that is. And that really is
Perfect.
helpful. All right. The second example is an implicit parameter. Kind of explain what's, oh, that's another thing is Alt-Enter, well, you can help set your imports. And then also when it's highlighted yellow like this, you can do Alt-Enter and it can make code suggestions for you, which is helpful, right? Okay, so in this example, we don't need to go too far into it, right? Is we've set an integer in the implicit scope, right, to 1024. And then I've defined a method here that accepts an int, and then that second parameter group, right, it always comes at the end, right, that's the variable from implicit scope that I want passed into this function, right? So we're setting that, like a side effect thing here, which is just my example. And then I'm generating a next int based off that, right? So when I actually call this method, you can see I'm not passing seed in explicitly. It's being passed through implicit scope into this function. So you'll tend to see that with things like execution contexts and application injectors and things more, core to your application, but maybe don't necessarily want to pass into every last method that you write. You wouldn't really use this for, say, some random variable, or at least in my opinion, you wouldn't.
So a slight bit of cognitive dissonance. If implicit val, the name is seed, and you got seed there, there's an implication that there's a meaning between the seeds.
Oh,
but
right.
if you rename the seed up there, or okay, yeah, rename that one
Yeah.
there.
Thank you for-
It's by type, not
Yeah.
by name.
Yeah, good point. So this is also the same thing as doing like that, right, explicitly.
Yes.
But anyways, the point of what I'm trying to show here is that I'm like, oops. Oh no, is this one not gonna work now? There you go. Is on the Mac, Command-Shift-P, and it shows you, implicit parameter and jumps to where. So it can help you kind of see where things are coming
Very
from when
nice.
that gets confusing. Right? Okay. Any questions so far? I know I went through that pretty quick. So that's Control-Q, Control-Shift-Q. Okay. So let's actually, now that I've mucked this all up, let's push this back to the original. Okay, so as you can see, this is an object under Scala Essentials, right? The package is Essentials, and I'm extending app. So I can just, this is a simple hello world, right? And I use IntelliJ. I mean, you can compile and run everything within. I'm just kind of always ran things in a separate command line. It's just the way I do stuff. So
Did you already clarify the difference between object hello extends app versus object and having a main function?
I'm just about to do that.
Okay, got it. Okay.
Okay, so here in the command line, I've started SVT, right? I'm in the project, and I can just type, well, first is pile, right? Okay, everything was successful, okay? And now I just want to run my program. Hello world, right? So extends app is, essentially, you're defining what your main function is here, and you don't have to sort of explicitly declare it. You can also do that if you should so like. All right, so I've declared my main function here. This kind of, to me, kind of feels old-fashioned, right? Because I don't need to do any of that. I can extend the app, and if I'm trying to get command line parameters, that args variable is available to me, right? It comes in through the tray, right? So just two ways of doing that. Pretty simple.
Is it possible to make the text a little bigger?
Yes, it is. I think. There we go.
Oh, okay, thanks.
All right, this is the same as I can type today, that'd be great. This type of thing, right? There's some differences, right? But essentially, you guys get the gist. Okay, so what's next on the list? Okay, so great. So that's our basic thing. We can, start building our application, and we want to write our unit tests, right, as we're going along. So like I said, we're using, in this project, we're using a library called Scala-3 and we'll look at what that test looks like. Oh no, I've messed everything up. So let me reset the project so that everything's back in the story. Okay. So we have, let's talk about Scala-3 a little bit. So Scala-3, you have, in fact, I have the links I want to show. How are we doing on time? All right.
16 minutes.
So on the Scala-3 website, you have select your testing styles. So there's lots of different testing styles that are available, right? And you can look through this on the Scala-3 website and kind of decide which one, fits for you. But there's different ways of writing them, and I don't really know if one is better than the other. It's just really kind of based on what your preference is. So we'll be looking at word spec, which is this one. So as you can see, it's more almost behavior driven. So in sort of plain English description of what you're trying to test. A set when empty should have size 0 and here's the assertion, that type of stuff. So if we look at our test, right, class hello spec extends unit spec, and you can see something similar, right? Hello should have a saying in, and then this assertion that hello.getText should be hello world, right? And when we run our test, right? Great, everything passed, all is well. We can go home for the day, right? Okay, so if we step into unit spec, these are basically different traits from the Scala-3 package that are providing different types of, useful testing definitions. So we have word spec, matchers. So we have matchers, which provides things like should and must and all these sort of checks. Option values that when we have an option and we want to test what's inside, right, we can just call that .value, and it's either going to give us what we want or it's going to throw a test failed exception. It's just sort of convenient testing mechanisms. Those are all listed on the Scala-3 website. So inside an inspector as well. So inside's like, I think it's inside where if you have like a nested tree of objects or whatever, you can use inside to kind of test what the values are and then give context in the error as to where things went wrong and things like that. All right, so back to hello spec. All right, so what happens if something goes wrong, right? Hello world. And I'm calling the SVT test, which fires up all of SVT, right? And then runs the test and shuts down. You don't have to do that. You can start SVT and then just keep writing tests. You can also put a tilde in front of test, and then it will detect when things change and then rerun your test for you, which can be helpful, right? So, okay, hello world is not equal to hello world with an extra exclamation point. That's a problem, right? And then two other things I want to mention is, so we're just doing test, right? That runs all tests. We can also do, that's large enough, test only, right? Right, we only have one test, so it's only going to run that, but you can use a wildcard in front of it and just match out specific, test specifications you want to run. And then you can also run test quick. If something failed, it just reruns the ones that failed. So I know I went through that pretty fast. Is there any questions? It's all on the Scala-3 website, and Oliver can just give it a read through. It's all pretty intuitive and easy to use. Okay, so I think that's it for basic application structure. And now I think there's some exercises. So thought we didn't we didn't have time to get to the exercises in section 2, so that might be a good thing to start with. If just go ahead and add methods to that hello world object, and you can add tests for them, and you can just go from there. And TAs will be around to help get things set up and help you guys go. And I'll give some time, and then we'll go through these answers. Go through these a little bit. Okay, so how did everyone do? All right. So we'll just walk through. Oops. All right. So first thing I did was I implemented some tests, right, for my functions, right. So as you can see, this is my input. This is what I want the output to be. Hello.reverse map should equal, the desired.
It doesn't emit anything.
Same for this, right? Word count. Scala's great. Scala's so cool. I run the method, so the word count for is, which appears twice, right? Should be 2. And then implemented some solutions. So I'll just kind of walk through what's happening here, and at least in this solution. So reverse map, right? So for each key, right, kind of like the similar syntax to the for each loop in Java, right? For each key in map.keys, right? We're going to yield the key.reverse and map.key.reverse. Now, obviously that's going to throw an exception and blow everything up if that key doesn't exist, but we're iterating through the keys that exist in the map. All right, so that's going to yield, all the pairs, right, that are going to be in this new map that we're creating, right? And then I'm just going to call result.toMap, right? So that's basically, remember how when Brian showed you could create a map, and in the constructor you could have key arrow value, right? Same type of thing. I'm just creating that list of key arrow values, and then I'm calling toMap1, right? Any questions on this? This is just one way to do it. It's just the way to do it. All right.
And you're sure that result to map is required? It wasn't able to pick up the tuples and automatically push it to map?
I don't know. Let's see. That would be even better. Is that automatically?
Nope, it came out as an interval string straight. So the 4 couldn't figure it out.
What if you could put parentheses around the...
Yeah, so yeah, you got to do the to map because it didn't make it out of the 4.
You mean put parentheses here?
Yeah, and at the end.
Well, if you do that, now don't you get rid of the arrow inside? You got to put a comma there, right? I don't think you can do...
I think it is essentially the same thing.
Yeah, that's what I thought. So if you glide over result, what do you get there? Yeah, you're still at interval. Okay, so that doesn't work. So you need to do to map still.
Cool. All right, so for word count, I did things a little bit differently here, and I can walk through what's happening. So we have our text, and this is just an example of more of a functional type approach, I guess, just for sake of examples of things you can do, because we haven't talked about any of this. So, but I get my text, right? I'm going to split it past the regular expression, right? So I'm splitting the string on space, right? And then group by allows me to take all those things, and I'm going to group by those things, right? So we can hover over it and see the type that's returned, right? So group by is going to return a map of the key and then an array of those things, because that's what I'm grouping by. And then I can call map values, right? Which is then saying, with that map, which has key to a list of those keys, I'm going to map through all the values, and I'm going to call length on it, right? So I end up with the word and the count of how many times that word exists, because I grouped by it, right?
It might help people visualize that if you actually draw it on the board real quick.
Sure.
What I'm talking about is what you have when you get done with the group by.
Okay. Sure. Or actually, I can
Yeah, like use Scala.
use
Scala fiddle or something where you're showing just each the things that are occurring.
this line by line. Wish this was smaller.
Yeah, it's like not useful. So does the output go down below?
I don't know what happened to it.
Remove the vowel split equals.
Oh, that's right. Sorry. Thank you.
Ah,
I am new to yes, whatever it's called.
No, just run
Leave that.
leave
Okay.
that, and then, yeah, it should, there we go. There we go.
Right?
It's an array of string.
So now we have an array of strings, right, that we split on this space. Right?
That looks like a string.
What?
It's like a string.
Yeah, yes.
Right? So there's nothing fancy about identity here. It's basically just saying we're grouping by the things that are in our list. Correct me if I'm wrong, Mark. Right?
That are equal to themselves.
Right.
There is magic with group by.
Yes. But I mean, I would have thought, when I originally was looking at this, I would have thought I could just done something like this, or just say, whatever I'm in my list, this is. So as you can see, it's gone through and it's grouped by all the words, right? So I've got cool, I've got is, which has in the string twice, right? Spell is great, it is so cool, right? So now I have a map of all the words, and then a list of all the words that we've grouped by, right? Whoops. Did I just break everything? What is happening?
The editor's trying to help you. Stop helping
Clean it
him.
down, nuke it. There we go. All right. So now, call this function map values. Underscore means I'm just referencing the element that I'm iterating over, right? And calling dot length. So now, right, it's taken those array of all those things we group by, and it's just called length on it, right? And so we end up with the count, right? Bool 1 is 2, Scala 1. So we've gone through this series of transformations on this data to get to where we want to be, right? We haven't destroyed our original data, right? It all still exists, right? And we've transformed it through these functions. We've put these functions together to achieve what we wanted to achieve. So that's kind of the direction that, when I first started learning Scala, it was very difficult to wrap my head around doing that. Go ahead.
How many hours would it take to write that in Java?
Let me start.
Oh, well.
Oh.
You're well on your way.
Type furiously.
It's
I'll get all the getters and
actually
setters.
implemented so much of, in fact, that was strongly influenced
So
by Scala.
if you put effort into learning the collections, learning the standard library, and all these methods that are available to you, and that's kind of like the Unix environment, right? Where you have all these individual tools and you're typing them together and doing more complex operations, right? And you can get a lot done quickly when you learn those things. Cool. All right, so
So can I point something out there in your val result for keys map up there?
yeah.
Yeah, there's actually an even simpler version where you actually suck the content of the map into a tuple. So
Okay.
so that's an interesting variation to mess with tuples. So when we go
Yeah.
back to experimenting, it'll be worth playing with.
Okay.
Can I see all that code in?
Yeah. Just get rid of this.
There we go. Oh my gosh. Colon. Math.
Okay, so when I started writing Java, I just killed my browser. Okay, so that was, where are we doing on time? 2:11? Mark, do we want to take a break, or do we want to move on to the next set of exercises, or what do you want to do?
Why don't we take like a 5-minute break?
Cool.
Can you put the code back since you're going?
Oh, yes.
Kaiso.
Write a unit test for the map key value reversing function that we had in exercise 2, and write a function that will transform a list of string to a list of double. Oh, and 6. Write a unit test of the code multiplication table printer. You wrote an exercise 1. Some of these exercises. The first one is write unit tests for map key value reversing function. I interpreted that, I think that the test interpreted it as reversing the strings rather than reversing the map, right? So that's the direction I went.
Yes. So the way we're doing the underscore method, that's what
Right, so.
Okay, so here's my simple example of the test, right? Pretty straightforward, right? Also, I should mention, is this working? Yes. Under inspectors, there's nicer, I think it's inspectors, there's nicer ways to test multi-dimensional arrays and stuff, so you don't have to do so much iteration, so I just call that out, it's in the documentation. Actually, I can show an example. Right, just doing something like that. So, a little bit easier to read, not quite so many variables floating around. Okay. Back, what was the next was write a function that will transform a list string to a list double. So this was my implementation that I did. So I'm mapping that and just calling to double, right? But that could throw an exception. So I just went ahead and wrapped that and tried. And I'm either returning, you know, it's going to return my list, or, you know, if there's a failure, it'll get list empty. There's better ways to do this. This? That? Here. Yes. Double. So I'm mapping over the strings inside of that list, and the underscore, I don't really need to give an explicit reference to it. So the underscore is just saying for my current thing.
And so that means your reverse maps and they're properly. And now you're testing it.
Also checking for exception.
Right.
Instead of returning
The
the
testing
test,
class is going to
Say that again? Yeah. I'm going to convert that feather into an empty list.
it'll be cleaner if it goes in.
Yeah.
Rather than doing tests.
Yeah.
Because then you can flat all the nuns will go away.
Yeah, yeah. Oh. And then unit test for the code multiplication table printer, you wrote in exercise 1. Which I did the same type of thing, basically just verifying, right, that the values that I produced are correct. But as I said before, I did it this way just to kind of be explicit, and but there's the inspector member class had helpers for this to make this, but I didn't want to have too much magic. So that's it. And that's it for my presentation. Mark's up next. I'm
I'm gonna have to
just
grab
in
my
under the wire.
laptop to get things set up.